Today we're gonna study about general chemistry, and I'm going to take you through all the parts that you should discuss today, and that is you should know about the atomic structure, but also chemical bonding. So aligning with the Tanzanian syllabus, general chemistry is going to be subdivided into atomic structure and chemical bonding. After we have known what we should be going through, then we can start learning about atomic structure. Now, when you talk about atomic structure, that you should remember that there are people around there who start thinking of how, like, what matter is made up of. Matter is made up of particles, the small particles, and there Democritus comes into the picture. And this scientist was a Greek scientist whose name is Democritus. Okay. Democritus. He was a Greek philosopher. He was a Greek scientist who said that all matters were made up of small particles. All matters were made up of small particles, and these particles were uncuttable. He gave the name atomos to those particles, which means uncuttable. So these particles could not be divided into more smaller particles, and this brought us to today's name, which is atom. But again, this scientist is not put in consideration very much these days, but he paved the way to the study of atoms from his idea of saying that matter is made up of small particles that are uncuttable or undivisible. Then every other scientist built up from that point. So other scientists who came after him was Aristotle. Aristotle was very against Democritus, because he said that all matters were made up of water, air, and fire. But that was not a great point in chemistry, because it doesn't have any proof or evidence or experiment that was done. But then another scientist came into the picture, and that was Dalton, who was a German scientist. And Dalton put forward five assumptions about the structure of an atom. He first said that all atoms are made up of matter, are made up of undivisible particles called atoms. And atoms can neither be created nor be destroyed. But also, assumption number 3 is that all matters are made up of atoms which have the same mass numbers. That means all atoms of the same element will be the same, and all atoms of different element will be different. But also he said that when atoms of different elements combine, they do so in small whole number ratios. But his postulates, all of them had shortcomings. When you look to today's atom, depending on how far the scientists have gone, we can now realize that atoms are divisible. We have 3 subparticles of atom, that is proton, neutron, and electron. Proton is positive charged, neutron is neutral, and electron is negatively charged. Proton has a mass of 1, neutron has a mass of 1, and electron has 1/1840 mass. So we have subatomic particles for atoms. So in that case, matter are made up of atoms, but atoms are divisible into 3 subatomic particles. But But again, you see that matter is, all atoms of the same element are the same. This is not true because of the presence of isotopes. Isotopes are the atoms of the same elements but with different mass numbers accounted by the number of protons and neutrons. So they are the same. They are atoms of the same element but they have different mass number. Example of isotopes are, maybe let's talk of chlorine. We have chlorine 36, chlorine 35, and chlorine 37. We can also talk of carbon 14 and carbon 15. Thallium, forgotten, I'm sorry. Okay, I don't write it. And again, but also you see that atoms of the same elements, atoms of different elements will be different. But this is not the case. That means they will have different mass numbers. We have atoms of different elements with the same number, like argon and calcium. They both have mass of 40, and they are also known as isobars because they are atoms of different elements but with the same mass number.